Welcome third graders to the Dallas Independent School District STEM Environmental Education Center. And we'd like to give a special welcome to the students at Marsalis Elementary, the third graders at Pleasant Grove Elementary, and the students at Arcadia Park Elementary. Welcome to our center. We know you can't be here in person today, but we are going to do our best to make you feel like you're here by doing some investigations here in our labs. So welcome. If you are watching this and you have not registered for this field trip yet, you can still do that by going to www.tiny.cc/EEC register to get yourself or your class registered for today's field trip. We just use that information for attendance purposes. And today's field trip is going to be all about changes in the state of matter. So during this virtual field trip, students will observe matter as solids, liquids, and gases. Students will also observe changes in the state of matter caused by heating or cooling. So we're going to start things off by giving you an overview of the states of matter. Then we're going to look at some changes in the state of matter. So you're going to see melting and condensation, evaporation, and then finally we're going to do a scavenger hunt and look for different states of matter here at the Environmental Education Center. While we're doing all of that, you can ask us questions, and we hope you do ask us questions. Since this is a virtual field trip, you will need to use this website. It's www.tiny.cc/EEC-question-answer. And when you get there, you'll fill out a very short form to ask us whatever question you like about states of matter. And you can ask as many questions as you like. And we will do our best to answer all of them in the time that we have with you this morning. So let's get started. We are going to start with that overview of states of matter with Ms. Nash.
Good morning, third grade. Welcome to my classroom. I'm Miss Nash, and today we're talking about 3 states of matter, and they are solid, liquid, and gas. Now, we can define them pretty easily. A solid is something that has a definite shape and volume, and there's lots of different solids around there. You can walk around and find all kinds of things. Some are heavy, some are light, but they're all solid. A liquid has a different volume. So volume is the amount of space it takes up, right? So a different volume of liquid in here, but it moves around. It takes the shape. If I tried to pick it up, I would just have a big mess on my hands. Now, a gas takes the shape and the volume of the container. So I got a balloon. I took a big breath of air, filled my lungs with air, which is a mixture of different gases, and I blew as hard as I could, all of the air out of my lungs. That's how much air was in my lungs. Wow. And I filled up the balloon and I tied it off. If I hadn't tied it off, it would have just escaped, right? So gas likes to escape. And we'll talk about that in a minute. So first of all, let's think about the fact that all living things are a mixture of those 3 things: solid, liquid, and gas, like us. We got bones inside, solid bones. We're made mostly liquid, actually. We got blood, and we breathe in that air. Now, my friend here, my little turtle friend, my little box turtle friend, he's got that solid shell on the outside to protect him. Sometimes solids are important for protection, like your skull. Really strong bone up there, and that turtle shell protects him. He drinks water, okay? And he like us, his body is like got a lot of water in it, and he breathes air, so he's got solid, liquid, and gas. Plants too. So you might think, okay, I see it's got a leaf, it's kind of solid, or stem, solid, and if I squeeze it really hard, it's got liquid inside. If I squeeze that orange, there's orange juice, okay, liquid. But there's gas in here also, because on the underside of a leaf, there are tiny holes that open and close, and they take in air to get carbon dioxide, and then they release oxygen. So it's actually air inside there also. Gases. Now, liquids take the shape of their container. So I've got 4 little containers here, and they look kind of different. Let's see how much liquid they have. What do you think? Let's pour this one in first. So it's got 200 milliliters of liquid, just water with fruit. Now, isn't that a cool bottle? My favorite. It had maple syrup in it once. And I poured this one in. Let's see, what do you think? I think, lug. It don't want to come out. 200 also. Weird. How about this big bowl? That must have more, don't you think? What do you think? The same again. Weird. What's going on? And this one, look at that. More for sure, right? But no, it's the same again. How weird is that? So all those different shape containers had the same amount of liquid. The liquids to take the shape of their container. Now gases, though, are really weird because they're everywhere all around us. And we've got the air, of course, it's a mixture of gas, mostly nitrogen. But there's other gases around too. So I've got my bottle of fizzy water here and got solid, got liquid in there, got some air in there. I already opened this one. Now, but there's another gas inside there too, besides that air. If I shake it up, see all that fizzing? See that pop? What was that? Well, what happened? I shook it up and there's a gas in there. And I made it kind of mad by shaking it, and it wanted to get out. So that's a pop. Okay. So there's carbon dioxide in there under pressure. And if I open it, and not right now, God, that fizz. But if I leave it overnight and then I go back to it, I'm going to drink it and I'm going to think, look, it doesn't taste right anymore. What happened? Well, all that gas in there, they're escape artists. They said, okay, now's our chance. Let's get out of here. And they dissipated into the air and mixed up with all the other gas. Now, because they're mostly invisible gases, they're kind of hard to imagine that they're there. So I take my plastic jug here, I squeeze as hard as I can. I put the top on. Okay, so there. And then, but what's going to happen when I open it up? That air, the gases are going to rush back in because they want to fill up all the space they can. They want to take up all the space they can. Now, on our planet Earth, there's only one substance that occurs naturally in all three states, and this ice is melting really quickly. But we've got solid ice, got liquid water, and if I leave this for a long time, it will evaporate, right? It will become vapor, evaporate, water vapor that becomes part of the air we breathe. So, another place you might find gases is in the stove. So you might be cooking with gas or heating your house with gas. But we can also, so this little canister here, this one's empty, but we go backpacking, hike up into the mountains, and we have to cook. We don't want to build a fire because that's not a good idea. So we take little canisters like this, and they've got a liquid in them under pressure. But then when I put my stove on top, it opens it up, and that it's going to become a gas now. It's isobutane and propane in here. And then I can light my stove and I can cook with this, the gas that's being released, okay, and I can burn that gas. Okay. Now, since you're in third grade, I want you to do me a favor, and I'm going to give you a little thing to do in this time. And take a piece of paper, fold it in 3 parts like that. And you're going to have solid, liquid, and gas. And because you're third grade, you can find 3 examples of each one. And solid, that's going to be really easy. Liquid, pretty easy also. Gases are a bit harder. Once we've gone through air, well, what is there? Well, my clue here is to think that most of the gases are invisible, but sometimes we can smell them. Like if I open my little stove here and turn it on, okay, there's nothing in it now, but if I turn it on, there's a little bit in there. But if I turn it on without lighting it, I can smell it. Okay? So you can smell the gases. Okay, that's to keep it safe. because they can hurt you. You go to the gas station and someone's pumping gas. Sometimes you smell that gasoline is becoming vaporized, becoming part of that mix of that gas. Okay, so that's your assignment. And if you have any questions, Mr. Rodden will answer.
Thank you, Ms. Nash. The question that came in was from Arcadia Park, and they asked, why do you use the gas stove instead of build a fire when you hike? And it's for safety reasons. The gas stove is much safer than building a fire. If you build a fire, you might start a forest fire, and you may have seen in the news those are happening in California right now. Another reason is when you go, if you wanted to build a fire, you could either take sticks with you, but you'd have to carry them the whole way on your hike, or you could gather sticks when you got there. If you carry sticks with you, that would be very heavy, and you're actually not supposed to gather sticks when you get there, because when you enter a park, the only thing you're supposed to take are pictures. All right, we're going to move on to changes in states of matter now, since we've seen solids, liquids, and gases. And Mr. Monroe is going to get us started off with those changes in states of matter.
Okay, good morning, third graders. My name is Mr. Monroe, and you're going to be spending just a few minutes with me, and we're going to explore and investigate two processes. And those processes are very important to us. They are very important for life on our planet. And it is concerning the change in the states of matter. The matter that we're going to be investigating is something that is essential to life on our planet. It's called water, H2O. And we have heard from Ms. Nash that water is one of the matters that it can be found on our planet, representing all three states: a liquid, a solid, and a gas. You know, the processes that we're going to be investigating are evaporation and condensation. First, we're going to look into evaporation. Students, right here, I have a beaker that is sitting on a hot plate, and the beaker has water in it, and I'm looking at the thermometer, and you guys know what a thermometer does. It measures how hot or cold something is, right? Well, I'm looking at the thermometer, and it's registering 225 degrees Fahrenheit, and it's pushing a little bit, tiny bit above 100 degrees Celsius, which means that's the boiling point for water, and it is boiling. I've been looking at this for the last minute, and I can see steam kind of coming up. I don't know whether you can see it, but what's happening there, we have accelerated a change in this water. In the beaker, it is liquid form. The steam that I see rising from it indicates that the liquid form is now changing into the gas form, which we call water vapor. When that process is going on, we call it evaporation. Very important. The changing of a liquid into a gas is evaporation, okay? Now, water has the ability to hold heat and absorb heat. But when the temperature of that heat that is in water, we call that latent heat. When it reaches a point, guess what? It changes into the gas form and is released all over. You know, I've got a very large aquarium in the back of my room, at the rear of my room, and there's a very large snapping turtle in there, and I know before I leave today or first thing in the morning, I'm going to have to put some more water in there because the water level has dropped. And you know, that snapping turtle, he didn't drink that water. So what happened to the water? Why is it down low? Well, that evaporation. In fact, you heard me say that heat accelerates the process, either by the sun shining on it or just external heat like we have this hot plate. Some time ago, I left a beaker with some water in it, okay? And I found the beaker, but it was completely dry. And I know that in that water, there was some other particles, some other chemicals. And when the water evaporated, changed into the gas form, guess what happened? it left some of those particles here. Stuff like chlorine and fluoride, stuff that would be in our water that comes out of our faucet. For example, even a puddle of water, you know, it's eventually going to dry up. It's going to dry up, and that is another example of evaporation. So there you have it. Evaporation is the changing of the liquid into a gas. Once that is a gas, it can also change to another state of matter, depending on, guess what? The temperature again. You know, air, it heats up and cools. If air gets cool enough, then it cannot hold the water vapor as the gas form anymore. The water vapor will then change into the liquid form. Now, I have a mason jar right here. I have a bowl of ice right here. And I'm going to fill this mason jar as full as I can get it with this ice. Boy, that ice is cold. Woo! Let me get my hand out of it. And I'm going to really cram it full. All the way. Drop a little piece right there. And I'm going to go ahead and shut this off because we've already talked about that. Oh, we got it. Now, I really hate that you are not here with us today, because if you were here with us today, I would have one of the students in this lab, you were sitting here with me, I would have them kind of keep an eye on what I was doing, and you guys can see it, but I would also need for that student, whoever it might be, to come up and make sure that I have dried the outside of this mason jar as dry as I can get it, okay? I'd have them come up and touch it, but I'm pretty sure you guys can kind of see it's dry. And you see how clear it is? You see the little pits, the particles of ice in it? Then the next step I would do is to get a jar of water. In fact, this time I'm using a scientific container called a flask. And what I'm going to do is pour water right down the middle of this jar. And as I pour the water down the middle of the jar, I don't want to get any on the outside. So that's when I'd have another student or the same student make sure there wasn't any water going down the side of the jar. Going right in the middle, a little at a time to make sure I don't spill it. The ice is melting. It's melting. And I'm going to stop it right there. Now, I didn't spill any water on the outside of the mason jar. We're going to let that set for just a minute. Now, you know, there's other processes that go on in our water cycle. And, you know, that makes this process that we call the water cycle very important to life on our planet, because water is constantly recycled over and over in our world. There is no new water in our world. The same water that we're using in our everyday lives, guys, is the same water that was here during the dinosaur times. Okay? That's some old water, isn't it? I can see that there's a change already going on with the mason jar. Okay? And I'm going to hold that up so you can probably see that change. See, it's not as clear as it once was. Now, it's not because the water's getting cloudy. What's happening is, on the outside of the mason jar, water is attaching itself to the outside of the jar. Now, just to prove that, I've got a little Kleenex here. Now, if you were here with us today, I would have a student come up and wipe their hand on that, and you would be able to see that it's wet. I'm going to wipe my hand on it, and I'm looking at my hand, and it is wet. It's got a little wet on it. So I'm going to take this Kleenex, and I'm going to press it up there, and it is wet. See the Kleenex sticking to it? So, if you were here with me today, and I'll even ask you guys this that are watching, how did the water get on the outside of this jar? You know, I've had students tell me, oh, Mr. Monroe, it came through the glass. And I'll have to tell them, nope. And they'll say, oh, you probably spilt just a little bit over the side. And I have to tell them, nope. When I explained to them how it really did happen, Guess what? They understand it. What happened is this, students. As the water was going down inside the middle and the ice began to melt, there was a cooling effect going on in the air around that jar. It cooled the air to the point to where the air could no longer hold the water vapor as a gas. So it changed it back into a liquid, and the liquid form of water condensed itself, attached itself on the outside of the jar. Okay? It's really wet now. Now, listen, guys. That happens in our atmosphere. We know that water vapor is all around us right now, in this room, outside. You breathe a little bit of it, as Ms. Nash had stated. It's in the atmosphere. So as water vapor travels all around, when that air temperature gets to the point to where the air can no longer hold the gas form of water vapor, and it changes back into the liquid form, just like this jar, it forms clouds because that water droplet that has formed from the water vapor has to have something to attach itself to. Dust particles and smoke particles that are in the air. And when that happens, guess what? Clouds will form, because we know that clouds are just a massive collection of water droplets. And to carry it just a little bit further, I know we're not studying the complete water cycle today, but when clouds get so saturated with water droplets and conditions get just right, then it falls back to the earth in the form of precipitation. So you can see how the changing of this particular matter, water, through evaporation, and then another change, changing it from the liquid form into the water, or changing it back from the gas form into the liquid form, forming clouds. You can see why that's so important to us all. Now, what I'm going to do, I'm going to turn it back over to Mr. Broughton in case some of you have some questions you might want to ask. Students, I want you guys to have a good time with us today. So I want you to enjoy the rest of your virtual field trip with us. And Mr. Broughton?
Thank you, Mr. Monroe. We didn't really get a question, but it was a comment. One student thought what you showed us was really cool. And third graders, if you thought that was cool, what we've got coming up is cool and literally cool. So Mrs. Fuller, why don't you show them what you have?
Hello, boys and girls. I'm going to be talking to you today about freezing, and it really is cold. I'm going to show you some information here. Ice melts at 32 degrees Fahrenheit, and water freezes at 32 degrees Fahrenheit. And water expands when it freezes. Now, Miss Nash told you that water exists in all three stages, solid, liquid, and gas, at regular temperature here on planet Earth. So as most things get really cold on planet Earth, they contract, they get smaller, they draw in. But water, which has a lot of very unique characteristics, does the opposite. When it freezes, it expands. So I want you to make a little water droplet with your hands and say, water, when it freezes, expands. It gets bigger. And I'm going to explain to you why. Now I'm going to show you some ice that I made in the freezer. And it's not flat on top. When I poured the water in, it was perfectly flat. But when it froze and it formed this dome shape up at the top. When water freezes, it increases in volume by about 9%, which is pretty remarkable. I mean, it's a lot. Well, why is that? Why does that happen? Well, because when it freezes, it forms crystals. And the crystals are six-sided. So you're real familiar with this, the snowflake. And how many points do you see on that snowflake? 6. Here's a different style of snowflake. How many points? 6. The snowflake has 6 points because the ice crystal forms as a hexagon. It's the same shape as a stop sign. A hexagon is a polygon with 6 sides. You learned that in mathematics. This is the shape of the ice crystal. Now, the reason why it forms as a hexagon is because of the polarity of the water molecule. As you know, the science name for water is H2O. Oxygen is a big atom, and the 2 little hydrogen atoms on top make it look a little bit like Mickey Mouse's outline. The end of the molecule where the 2 hydrogen atoms are, that's slightly positive. The end of the atom where the big oxygen atom is slightly negative. So it has poles, just like our planet has poles. So when they attach to each other in the crystal making process, they attach as a lattice of a 6-sided shape, and in the middle is space. So instead of it being flat like this, it's got space in it, which causes the ice to be bigger than the water. So this is water. The water is very heavy. It's one of the unique characteristics. 1 cubic meter of water is equal to 1 metric ton. So it's very heavy. Things that float on water, we say, are less dense. Ice is less dense than water because that hexagonal shape of the lattice of the water crystal. So that's why when you freeze water, it gets bigger, it expands. I'm going to take this ice and I'm going to put it in the water. Is it going to sink or is it going to float? It's very heavy. Whoa, it floated. All right. This is very important to life on Earth for ice to float. If you think about it, if ice sank, then the lakes in the wintertime would freeze from the bottom up instead of from the top down. That way there'd be no place for the fish to hide. Now, because ice floats on water, because it's less dense, if it freezes, it's going to freeze the top, and the fish can go to the bottom of the lake to hide from the cold ice at the top. So that's really important. Now we're going to talk about one other little thing here, and that has to do with sublimation. I'm going to show you how the word is written. Sublimation. We have 3 phases of matter. We've got solid, liquid, and gas. We know that when ice melts, it turns into water. But did you know that ice can also go straight to the gaseous form? It doesn't have to melt first. That's called sublimation. And you've seen it before in your kitchen at your house. How many of you have pulled out a tray of ice cubes, and it was a tray that was in the back of the freezer? Whoops. And instead of it being a big ice cube like you need to make your Kool-Aid or your iced tea cold, it was a little one about half the size of a regular one. So you put your thinking cap on. When you filled the ice tray, you filled all the little squares, all the little rectangles up to the very top. Why is this smaller, especially since we know that water expands when it freezes? Well, what happened was it stayed in your freezer so long that it sublimated. It changed from the solid state to the gas state. The reason why that happens in our freezers with water and ice is because of the very, very low humidity in our freezers. A long time ago, when I was in the 3rd grade, our refrigerators had very small freezer compartments, and they would get a layer of ice on the inside. And we had to do something called defrosting the freezer. And you had to put a heat lamp on it and get all that ice loose and pull it out. And the reason why was that there was humidity in the refrigerator and the freezer. Now the freezer is separate from the refrigerator part, and it's very well insulated, and they keep the humidity in there very low so it doesn't build up that ice around the walls. Well, as a result, sometimes our ice cubes will sublimate. They will go from the solid ice cube to a gas inside the refrigerator. The gas is water vapor. There, I'll give you another example of sublimation that doesn't have to do with water, and that's dry ice. At Halloween time, sometimes you go on people's porches when you trick or treat, and they'll have a bucket or a bowl, and it looks like it has fog in it. And the fog will go down on the porch. Well, it's not really fog, it's dry ice. And what happens to dry ice when it's exposed to the air? It sublimates. It moves from the solid dry ice straight to a gas. The gas is carbon dioxide, and it doesn't go to the liquid state. There's not enough air pressure on our planet for carbon dioxide to be a liquid, but it can exist here as a solid and as a gas, carbon dioxide. So that, and put that down. So we're going to remember a few things. We're going to remember the ice crystal is a hexagon, and there's space in the middle. That's why water, when it freezes, expands. It gets bigger. Mr. Broughton is going to answer any questions about freezing that you might have. Have a delightful day. Bye-bye.
Thank you, Mrs. Fuller. And the question that came in was, how does water freeze? And there was no name given, but I think it was from Arcadia Park. Water freezes when you lower the temperature down to 32 degrees Fahrenheit. It will change from a liquid to a solid. And then another question was, how can the freezing point and melting point of water be 32 degrees Fahrenheit? And that just depends on what state you're starting from. So if you start with ice and raise that temperature to 32 degrees Fahrenheit, it will melt and become water. If you start with water and lower that temperature to 32 degrees Fahrenheit, it will freeze and become ice. All right, we're going to move on to our States of Matter scavenger hunt with Ms. Ramirez.
Hello, 3rd grade. My name is Ms. Ramirez, and in this segment, we're just going to do a quick review of what y'all learned today, and then we'll get to our scavenger hunt. So to review what y'all learned today, we're going to use an animal guest to help us remember the states of matter. So this little animal is a little baby chick. And how do you think this baby chick depends on solids, liquids, and gases? So we're going to start with solids. So our little baby chick depends on solids, like solid foods to eat. Right now he's eating pellets. So that's how he depends on solids. Also, our baby chick is a vertebrate animal. So that means he has a backbone and he has other bones in his body. This is an example of an animal that I found outside, and you can see these nice solid bones that this animal had. So, as Mrs. Nash mentioned before, many animals have all states of matter in them, whether it's bones, liquids, and gases. Now, can you think of any animals that might not have bones? So that might be a thinking question for you guys. So we said our little bird here depends on solids. And again, solids are just materials that have tightly packed particles. They have a definite shape and a definite volume. Solids that you might have at home near you might be things like pencils, pens, your desk, your house or your apartment, the materials that are used to build those. Now, how do you think our little bird depends on liquids? Well, our bird needs water to drink and stay hydrated. So you can see the water in this container is taking the shape of the container. And when I pour it inside the little drinking bowl, it's going to take the shape of the drinking bowl. So our little bird depends on water to drink, and his body also has water and blood inside of it. So liquids are just loosely packed, those particles. They take the shape of their container, and they have a definite volume, just like our solid. Now, how do you think our little bird friend here depends on gases? So he actually has gases inside his body, and he depends on oxygen and air to breathe, just like we do. So that's our states of matter. So what I want you guys to do next is to either take out your science journal if you have one, or just find a piece of paper and something to write with. And what you're going to do, you're going to take your paper and you're going to fold it just like this so that you have 3 columns. Once you have your 3 columns, you're going to write solid in the first column, liquid in the second column, and then gas in the third column. So for our scavenger hunt, we're going to go on a virtual scavenger hunt of the Environmental Center, and you're going to be on the lookout for different solids, liquids, and gases. Now, earlier with Ms. Nash, we learned that we can't see a lot of our gases. So what are some ways that we know gases exist? So be thinking about that as we watch the video. So again, while I get the video started, make sure you have something to write with, and then a paper so that you can make some notes and write down what you see. I'm going to share my screen. And again, since y'all can't be here with us, this is just some video of what we have here at our Environmental Center. And let me start that video for you guys. So this is our indoor habitat museum. You can see some taxidermied birds. You might even spot a coyote hiding out somewhere. You can hear the water flowing. We have an aquarium with lots of fish. So how do you think those fish depend on the states of matter? We have some red-eared sliders. And then I hope you notice those bubbles that are forming. These are rain barrels. They collect rain from the gutters. This is our windmill. It actually pumps water to one of our ponds. And what do you think powers that windmill? This is an anemometer. It measures wind speed. And below it is a rain gauge that measures the amount of precipitation. And hopefully you can see our little A&M windsock blowing in the wind. And then we're going to see another science tool, the thermometer. It measures air temperature. And it was a rather warm day yesterday. This is the Osage orange tree. Some people call it the hedge tree or the horse apple. Some more bones I found yesterday. So we do have a lot of predators out here at the Environmental Center. This is an image of algae in our pond. We also have a pipe that has that running water that's coming from our windmill. This is one of our calves. I think this one is Sarah, and she's eating her pellets. She has a very wet, rough tongue. And she did leave a lot of spit or saliva on my hand. So what state of matter would that be? This is our turkey, Mr. Gobbles. What do you think his beak and claws are made out of? These are some hissing cockroaches. They are invertebrates, so they don't have bones. They don't have the backbones. Again, bubbles. Why do you think those bubbles are important for our fish? And what animal do you think lives in this habitat? So this is our ball python. How do you think she depends on solids, liquids, and gases? This is a tractor I saw this morning. Look at its small tire. What do you think happened to that tire? This is our dried up pond. What do you think happened to that water? I will say that pond is no longer there. These are our dabbling ducks. They are looking for food. How do you think they depend on water? And we're going to go ahead and stop it right about there. We're going to go back to our presentation screen and we'll talk about some of the things that y'all observed. So hopefully you were able to at least come up with a few examples of solids, liquids, and gases. These were some of the examples I came up with. So for our solids, I noticed the metal on the windmill was a solid. That green horse apple that was in the tree is a solid. The wood posts that were inside our museum were a solid, as well as our building, the bricks that make up our building. The food pellets that I was feeding to our cow, those are solids. The rain barrel outside was also a solid. And then those cool bones that we found outside are examples of solids. The liquids, we saw a lot of liquids today. So all the water that was inside our aquariums, the water that was inside the snake habitat. So the snake does drink water. A lot of our animals have water in their habitats because they need that to drink, just like we do. The water that was in the ponds, the water in the rain gauge, the water that's in the rain barrels that you saw outside. So those are all examples of liquids. The gases, remember those bubbles I asked you guys to observe? Those bubbles are super important to our aquatic animals because it incorporates more air and oxygen into the water. So just like us, fish need air. They need oxygen to breathe. The windmill, even though we didn't see the wind, we know it's there because we saw the windmill moving. We saw the windsock blowing in the wind, and we saw the anemometer turning because of the wind. Also, that tire from the tractor, I think it had a low tire, that small one that looked like it was flat. So there is air in our tires. And then, of course, the air that we are all breathing right now. We might not see it, but we know it's there. So those are all examples of gases. So before we go, I just have a couple of reflection questions. My first one is, how do the plants and animals and you depend on solids, liquids, and gases? So be thinking about some of those animals and plants that we saw in the video today. How do they depend on the states of matter? My second challenge question for you guys is, did you observe any evidence of changes in the states of matter as it regards to water? So when the water freezes, what's going to happen to it? And when the water gets heated up, what's going to happen to it? So think about the pond outside that you guys saw today, or the puddle that the ducks were in. What's going to happen to that water as the seasons change and the temperature changes? So think about how the changing states of water might affect our farm animals out here. And that's all I have for you guys today for your review on the states of matter. We're going to go ahead and pass it back to Mr. Broughton, and he's going to answer any questions that y'all might have.
Thank you, Ms. Ramirez. And got a number of questions. Are snowflakes made in clouds? Yes. So when water evaporates, it goes up into the atmosphere where it cools, and then it condenses to form clouds. And then when those water droplets get big enough, they will fall. And if it's not cold, they will fall as rain. But if it is cold, they will fall as snow. So they are made in the clouds. Somebody commented that that chick was cute. Let's see. How does water turn to gas? From Brianna, water will turn to gas if you heat it up. It will change from a liquid to a gas, but you have to add heat. Another question is, why are bubbles important? I think that in the aquarium, they are important because they put oxygen in the water for fishes to breathe. And so another question was, how do fish breathe? And they breathe with their gills. So they don't have lungs like we do. They have gills that can take that water and filter, or the oxygen and filtered out of the water to breathe. And thank you, Mrs. Salaceda, for joining us. We hope to see you at the next field trip in 3 weeks as well. So I'm going to share my screen here with you, and we'll do a quick little recap of what we covered today. So there we go. We explored changes in the state of matter. So during this virtual field trip, you observed matter as solids, liquids, and gases. Students also observed changes in the state of matter caused by heating and cooling. So we looked at all three states of matter, solids, liquids, and gases, and we observed melting, condensation, evaporation, freezing, and we wrapped things up with the states of matter scavenger hunt. Thank you so much for joining us this morning. We would love to know what you thought about this field trip, and you can let us know by going to www.tiny.cc/EEC feedback. To fill out a short form, it only takes about a minute to complete. To let us know what you thought. We value your opinion, And we use your comments to improve what we do here. And we'll see you again in 3 weeks. Bye-bye.